Welcome back to the Foundation in C# course. We're currently in Module 8, and this lesson we're going to be covering how to access SQL Server data inside of C#. Okay, so that's our focus. We've already gone over the theory behind our database structure. We've gone over what ORM we're going to use. Now let's get practical and actually do it. All right, so let's go to Visual Studio. And we're going to create a new project. So let's go to New Project. We're going to create a console project. And that may sound weird because console application is a very, very simplistic user interface. And some people want to say, well, but I want to see how you do it for ASP.NET MVC, or I want to see how you do it in WPF. Here's what I want to make sure you hear from me. Your user interface has no bearing on how you get data. It should not. If you're trying to connect your database directly to your user interface, your application design has a problem. Okay? You do not want to have that direct connection. We're going to do all of our work to connect to the database in a class library. That class library, the same class library, can be used in any .NET user interface, whether it's ASP.NET Core MVC or Razor Pages or MVC .NET Framework or WPF or WPF.Core or WinForms or, in this case, console applications. It doesn't matter. Okay? So I'm going to use a console application because it's the simplest thing to do. It's very, very simple. And it gets us just our code. We don't have to worry about UI setup. Okay? That's not the focus of this, is UI setup. The focus is on writing good C# code. Okay? So console application, we're going to call this our SQL Server UI. And we're going to call the solution name the Relational DB solution. And the reason why is because we're going to use this same solution over and over again. We're not going to create multiple solutions in this first section here. So we're going to create a section for accessing SQL, another one for SQLite, and another one for MySQL. And we're going to use the same class library for all three, even though we're going to talk to different databases. We'll use a different user interface just so we can keep that code separate. But what I want to illustrate here is just how closely the three different database projects, how closely their code looks to each other. So we're going to keep them in the same class or the same same class library so that you can kind of see side by side how they work. Okay? So let's hit create. And the first thing we'll do is we will remove the console write line hello world. And we'll do a console read line at the end to stop our application from closing out Now, if you haven't installed SQL Server before, SQL Server Developer Edition is free to download and use. It's the equivalent of SQL Server Enterprise Edition, meaning it's got all the bells and whistles. But Developer Edition is free. It's not for use in production, but when you're developing, it's a great tool to have, and it's great to have installed on your machine. However, that is a pretty big installation. In fact, in my SQL Server Developer course, that's one of the videos covers just how to install it and how to configure it. In this video, we're not going to do that. Instead, what we're going to do is use what's called local DB, which is a SQL Server version that is really, really tiny and it's just used for development. Okay, so what we're going to do first is make sure you have installed the correct tools. In Visual Studio, if you go to Tools, Get Tools and Features, the first option, it's going to give you a UAC prompt, and then it's going to give you this page right here. Once it does and it launches up, it's going to show you this layout. And this is what you selected when you first installed Visual Studio. Now, I have a lot installed because of the fact that I teach a lot of different areas. You don't have to have all of these things installed, but I am going to show you what you do need installed to follow along. If you scroll down, you're going to find an entry here called Data Storage and Processing. Make sure that box is checked. When you do, over here on the right, you'll see Data Storage and Processing, and you'll have these 4 optional checkboxes. Make sure at the very least that the top one, SQL Server Data Tools, has been checked. If it hasn't, check the box. Make sure that you install, and then once it reboots and once it's fully installed, then you can follow along with what we're going to do in these videos. That will install the SQL Server Data Tools, which will also install the local DB, which I believe you can find under ASP.NET and Web Development. Nope, Desktop Development. That's what it is. There we go. It's down in here. I thought it was in here. It's in one of these settings. There's going to be an option for local DB. If you're not sure, if you're not sure, individual components, it'll be in here for local DB, and there you go. That's why it's SQL Server Express 2016 local DB. I was just scanning for local DB. It's probably in this list, and I probably just missed it because I was not looking for SQL. There we go. So it's under .NET Desktop Development. But either way, it's going to check that box because it's needed for the SQL Server Data Tools. But just in case it wasn't for whatever reason, make sure that box is checked. Okay? So essentially just check this box here, down here. Data Storage and Processing. Install that. Once it's done, then you'll be good to go for this next step, which is right-click on the solution, add, new project, and this time we're going to search for SQL Server Database Project. I'm going to undo my selection of C# because it's actually not listed as C#. It's a query language is one of the tags. So SQL Server Database Project. Okay? I want you to install that, or install that project. And let's establish a naming convention of SQL Contacts DB. Okay? So we'll call the SQLite database SQLite Contacts DB, and we'll call the MySQL database MySQL Contacts DB. Okay? So this is SQLite Contact DB. This is a show you store procedures or not. I think not, just to keep in line with what everything else does. I use store procedures inside of SQL Server. I do not use store procedures for MySQL or for SQLite. So in order to keep that apples to apples comparison, I'm just going to run basic queries. I'm not going to do an actual store procedure. Essentially, all a store procedure does is it wraps a query in a statement. It makes it a little easier to call. That's, from your perspective, that's all it does. Now, it does sometimes make it more efficient to do it that way, and it allows you to do more than one statement at a time. Okay? But in this case, let's do this. Let's add a right-click on tables and say add table. Now remember, we have our table design that we went through, so we kind of already know what our table should be. So let's create contacts, which is our first table. And that contacts table already has an ID in here, its primary key. We do want to make it an identity. So down here in the T-SQL, we'll just type identity. Well, varchar is a data type, and varchar means variable character with a max length of, in this case, 50. So that means I can store my first name in there, TIM, and that's all the field will hold, is those three characters. That's the var, okay? Because a char 50 will also hold TIM in there, but if the max length is 50, it's going to say TIM and then have 47 spaces in order to have exactly 50 characters. That's typically not what you want. Therefore, varchar. Okay? Now, there's also another type called nvarchar. Again, this is not a SQL course necessarily, but I do want to point these things out, the basics, the foundations. Nvarchar, the difference is it will hold Unicode characters, meaning characters outside the typical, what we'd call typical English alphabet. Okay, so ABC, uppercase and lowercase, numbers, special characters, those are all, they fit very well into the varchar. Unicode is for characters that would fall outside of that range. So accents on letters, or anything with an Asian style lettering where it's like pictographs. Okay, those type of things. Arabic in any flavor of writing is going to be different than what you'd be able to store in a varchar field. So if you have a thought that maybe your values are going to be outside of the ASCII alphabet, okay, then you want to use nvarchar, which means you may ask, why would we ever use varchar? Why wouldn't we always use nvarchar? Well, the difference is the size. An nvarchar character takes up twice as much space as a varchar character. Therefore, if space is an issue, which is not typically anymore, but it's something to think through. If space is an issue, then varchar, when it is appropriate, is more efficient. Okay? Now in our case, let's go ahead and change these. I can come down here and just say n in front of them. And now they're n varchar, which means that they allow Unicode, their variable length, and these are characters. Okay? So now we have an n varchar for first name and for last name. And that's all we'll do for the context table. Now I'm following along with the slide that we created earlier, we saw earlier, this section over here on the right. Okay? That's what we're going to create. So I'm going to create these first, these 3 in this first column, and then I'll create the 2 on the far right. So next, I'm going to create another table. And this time we'll call it email addresses. Make it identity. Then come up here. This designer is a whole lot easier to work with than SQL Server Management Studio. SQL Server Management Studio used to be the only option for creating databases, or one of the primary options for creating databases. But now with SQL Server Data Tools in Visual Studio, this is a lot easier for developing the database. SQL Server Management Studio is better for maintaining the database, the management of it. And one of the benefits of this right here is I can use either pane. So when it's easy to type identity, I do that, versus coming up here and then going over and go to properties and find identity and turn it on and make sure these 2 are set. Okay? So that's just one of the benefits. All right? Email address. Again, nvarchar. How long? That's up to you. Let's just say 100. An email address does have a max length, or I say not null. And that's up to you if what you want to support is the max theoretical length, what you want to support, or do you want to work with something that's more reasonable, and anything above that you're saying I can't take that email address. For the sake of our design, nvarchar 100 is just fine. Okay, that's all that table needs. Let's create one more for phone numbers. Identity. If you get in a rhythm of how to do this, then it becomes easier and easier to work with. Okay, and phone number, and that's going to be, this is what that trips people up. I'm going to choose varchar, and I'm going to say that 20. And I'm not going to allow nulls. Okay, so the reason I said it's a variable character and not a number is because a phone number is not a number. Repeat that after me. A phone number is not a number because it may feel like that. Let's do it right here, where you say 212-555-1212. That's a phone number, right? And you say yes, but those dashes aren't numbers. Well, no problem, because really we could store it in a database like this, and that's all good. True. What's the extension? Okay, and normally you'd say, well, the extension is extension 123. But you can't store spaces or the ext. So now you have that, which does not look like a valid phone number, and you've got a problem because you don't know, is that first number the country code, the first 2 numbers the country code, and then the number? And you have to figure out, okay, if the first 2 numbers are the country code, then we've got the area code and the first 3 numbers, and then the last 4, and we got an extra one. Well, that's okay because the countries do things, different countries do things differently, and also you figure out that you don't know how to parse this number. That's why those indicators are good because they make things a little clearer. Okay, that you now know how to parse. You can even store it in a way that your C# code knows how to process that if it's going to actually make the phone call. The reason we don't store phone numbers as numbers anywhere is because of the fact they're not numbers. I know it says number in the name, but it's not a number. A number you can add, subtract, multiply, and divide. Is there any point to multiplying your phone number? No. It's not going to give you value in any way. Therefore, store them as strings. That allows you to do things like this and make your value easier to read and use. Okay, so we now have phone number. Now we're going to create those two tables that link the others, allow for the multiple read, multiple or linking, many-to-many relationship. Boy, I had my brain was not quite working there. So many-to-many relationship where we can have many contacts that use the same phone number. We can have many phone numbers for one contact, either way. All right. So we're going to have contact email table. Make it identity. We'll come up here and we're going to say contact ID int, not null, and then email address ID int. And you may ask, well, why do you call it contact ID? My naming convention here, and it's one that's pretty common, is that I use, when it's a primary key, I call it in this demo, I'm not going to keep recreating these tables or modifying them, hopefully. So I'm not going to save this published profile. I also don't want to save it because I want you to have your own. I don't want you to try and use mine and then break something on your system. I'm going to say edit. I'm going to choose browse local MS SQL local DB. Hit OK. The name of a database is going to be SQL Contacts DB. This is up to you what you choose. You don't have to choose this name. You could choose a different one. I'm going to choose SQL Contacts DB. Again, you could say save profile right now, and it will save this profile. However, I'll just hit publish. And once, notice down here the data tools operations is opened up. Once this is done publishing and it's done, we can open up databases, and we should see the SQL Contacts DB, which we don't yet. Let's refresh this. And now SQL Contacts DB is here. And under tables, we now have all of our tables, all of which are empty. That was a lot of setup, but now we have our database. Now, in the future, we're going to go a little bit faster than this because we don't need to talk through every single one. But I did want to give you that good foundation to start, especially with SQL Server. Because, and this is important, the number one database to go with C# is SQL Server. If you have a SQL or a C# application and you have data, which you almost always do, in a business environment, you will most likely be using SQL Server. That's not the only database you can choose, but that's the most common one used with C#. All right? So again, I'm not saying that's the only one you can use or it's the only one you should use. It's just the most common. So I did want to take a little bit extra time. I do encourage people when you're learning C#, when you get to a certain point, learn some SQL as well. Okay, now let's move on to actually talking to this database. The first thing we need to do, let's collapse down this database project. We don't need it anymore now it's created. The first thing we need to do is we need to get a connection string to this database. Now we're going to get the connection string in the console because we don't want the class library knowing how to get that. There's no reason to pass that down. We're not going to go full into .NET Core and creating dependency injection because that's a little beyond the scope of this course. But let's at least create a little bit of work inside of our console to get that connection string, which we don't even have a place to store yet. So let's right click on SQL Server UI. We're going to say add new item, JSON, and we're going to say we want to have a JSON file called app settings.json. All right, this is a pretty standard file. Normally it comes with most projects. So ASP.NET Core projects will have this by default. And it's going to be coming to console and other projects soon because of the fact that it's a standard way of doing things. However, it's not in by default in this current template in .NET Core 3.0. So we're going to add it ourselves. And here we're going to say, in quotes, connection strings, colon, and have curly braces. And we're going to say default, colon, and it'll have our connection string. Now our connection string is the string that tells us, or tells our application, how to talk to our database. It has things like, where is the database located? What's the IP address or path or whatever it is we're going to connect to it. Maybe it's network name. And then once we're connected to the server, what's the name of the database itself we're talking to? Because a server can have more than one database, as you see in my database list, which I have a lot. And then it's going to say, now we know where it's located and what it's named, how do we talk to it? Is it based upon the user's security who's logged in, or is it a username and password? and some other information. There's a lot of information that can go in a connection string. If you're ever not sure how to build a connection string, you can go to connectionstrings.com. So it's connectionstrings, plural.com. And it will give you the patterns that you just basically fill the blanks in. Okay? But in our case, with SQL Context DB, if I right click and go to Properties, one of the options down here is Connection String. Just double click to highlight the whole thing, Control C, come up here and Control V. Now what this does, it pastes in the entire connection string. Honestly, not everything in here is necessary, but it is helpful. So first of all, where are you going to find it? Well, there's the location. First of all, local DB, which is the local DB on this machine, and then it's named MS SQL local DB. The initial catalog, which is also known as the database name, SQL Context DB. Start by getting that value out of the app-settings.json. I'm in my class program static void main. Let's create a private static string get connection string, and we're going to pass in a string connection string name, and we're going to say equals default. All right. What that's going to do is we're going to look for our connection string. Remember, I named this default. By default, we're going to say that's the one you're looking for. So you don't pass in a parameter. That's the value you're going to get is default. However, if we have a second connection string, we could pass in a different name and we'll get that one instead. Now let's create our string output, which we will fill in a minute. All right. Now let's talk and see if we can talk to our app-settings.json. Let's start by creating a connection that will talk to the app settings that's built in kind of as part of a NuGet package, but it's a typical way of doing this. Okay, so we'll say var builder equals new configuration builder, which I don't have one yet because I have to install a NuGet package. So let's install the NuGet package by going to right click on dependencies and saying manage NuGet packages. And under browse, I'm going to say Microsoft.extensions.configuration. Microsoft.extensions. If I can talk and type at the same time, .configuration.json. All right, this is going to allow us to talk to a JSON store like app-settings.json. It will also install the base Microsoft.extensions.configuration that we need. So install this, accept, and now we've installed it. We can come back over here and do a control dot and add the using statement for using Microsoft.extensions.configuration. Now that we have this, on the next line we can say dot set base path directory control dot to add a using for system.io. So directory dot get current directory. And the next line we're going to say dot add JSON file. And we'll say app settings.json. Okay? And that's going to load up a builder or configuration builder, and we'll pull in that app settings.json file. We're not quite done yet though. We do have to say var config equals builder.build. Okay, build that configuration. Now we can say output equals config.get connection string. And we pass in the connection string name, which is going. Now we have the connection string being returned. Let's just make sure it's correct by saying get connection string. So we're going to call that method inside of a console write line. So the return value, that string, will get printed out to the console. Let's run this and make sure it works. It's always good to test as early as possible. There's our application starting, and it's not going to work yet. It's going to blow up and say, I can't find the file, and it's not optional. Okay, why is that? Well, let's stop and find out. My guess is under properties here, we had not set this to copy. Okay, copy if newer. Let's try it again. There we go. Now it's running and it says data source equals local DB, MS local DB, initial catalog is SQL contacts DB, and so on. So it has our connection string. So now that that's working, this get connection string, now I can pass this on to our data access library and say, hey, here's the connection string for your SQL server. Now give me the information. So let's wipe out our test line here. This is also where unit testing would be great. We just create a unit test for this and make sure that it actually gets back the correct connection string. But again, that's kind of beyond the scope of this foundation course for data access. All right, now in our data access, we can right-click on dependencies and say Manage NuGet Packages. And here we want to install Dapper. And right now the stable version is 2.0.30. It's up to you which version you use, but the latest stable is almost always the right choice. Hit install. And now that's installed, we can right click and say add new class. And we'll call this SQL Data Access. Make it public. And in here, what we're going to do is we're going to create a couple of methods. and that's called as a U, but 1 is the return type. Okay? So now we have to specify these two types when we're calling this. Why am I going to use these generics? Well, because I'm going to do this. Using IDB connection, control dot here to add the using system dot data. Connection equals new SQL connection. Control dot to add a using for install package system.data.sql client. Okay, find and install the latest version. And then after that, we're going to pass in our connection string. Okay, so now we have our using statement. And now in here, we can say list of type T rows equals connection dot query. Control dot here to add a using for Dapper of type T. I'm going to explain this in just a minute. SQL statement, parameters, and that will be it. Oops, we have a to list, which control dot again for using system.link. And now we can say return rows. That's all the code we really need, and it's a lot of generic stuff. So let's talk through what it's doing. Okay? We're going to create a connection to our database. And we do that in a using statement. A using statement allows you to ensure that you're always closing out your connection properly. So I'm going to say create a connection to the database, but no matter what. It doesn't matter if my application succeeds, if it fails, if it crashes, if it has an unhandled exception, if it has a handled exception, it does not matter. It will always close the connection to my database. Okay? That's why it's in the using statement, to make that happen, to force that to happen. So I create a connection to a SQL connection to my SQL server. Now it's a local DB, which is a SQL server. It's just a local DB version of that. So there's my connection string. So I'm saying connect for a SQL server, connect to, again, that location, that path, that database name, using those credentials, and so on. Once it creates that connection, then I'm going to say query. This is a Dapper thing. This again, a model. And so in our case, we're going to pass in a model that represents one row of data. So first name, last name, email address, phone number, whatever is in that row, we're going to have a model that represents that. That's what type T is. And so it's going to say, okay, for every row, I'm going to put it into this model type. And it's going to have a set of those. Normally, it's an IEnumerable. In our case, we want an actual list of T, not an IEnumerable. Therefore, we're going to do a toList at the end of it and get back a list of T, that model type, for the rows. We're going to return those rows. So we're going to pass in a SQL statement and any limiting parameters and which place to connect to. We're going to get back a list of rows, but in strongly typed models. Okay, that's what our ORM is going to do for us. So that right there is Dapper. That's what it's doing. That's pretty much it. Okay, that's for loading data. Now, we're going to create another one for saving data. Public, void, is not going to return anything. Save data of type T, where string SQL statement, T parameters, and string connection string. Now, using, again, that using statement, IDB connection. Sound familiar? Connection equals new SQL connection string. I mean, so far it's exactly the same. It's just what's inside is different. Connection.execute. This is a write instead of a read. So query is a read. Execute is a write. SQL statement. And then we have our parameters. That's it. So it's the same thing, same idea. It's just this time we are going to execute our store procedure, meaning, or our SQL statement. So we're going to say insert into database. Now, we're going to have some parameters this time for sure, because when you're inserting a record, or if you're deleting a record, or if you're updating a record, you're going to have, here's the record to do that on, if it already exists. Either way, here's the data you need for that command. And so we'll have that. We're going to pass it in as type T, though, which is generic. So that's our setup code. Now, is this a little confusing? Probably. And if you're getting a little lost, don't worry. Don't panic. This is setup code. It will make sense in a minute. And we're going to do this 3 times. We're going to do this for SQL Server, and you'll see how it works. And then we'll do it again for SQLite, and you'll see how it works. And we'll do it again, and you'll see how it works for MySQL. So this same code, or very, very similar code, we're going to do 3 times. And so hopefully that 3rd time, it's going to be clicking more than it is right now. All right? And it is hard. It's hard to figure out where do you write the code next, because until you get the whole process working, you can see it work, it's sometimes hard to visualize. And so we're just going to have to just do this for now, and then you'll see it work, and you can visualize it, and you can try it again and visualize it, and then try it again the 3rd time and visualize it, okay? Sometimes it takes a few times of practice before it kind of sinks in. So again, don't worry if you feel a little bit lost. Now, let's create a new class. Let's call this class SQL CRUD. Now, CRUD again stands for create, read, update, and delete. I would probably name this something nicer for a quote-unquote real application, but for this, it most easily points you to what this is doing, okay? So that's actually a good name for this sample application, I think at least. Make the class public, and then inside here, we're going to use that SQL data access. So let's create a few methods in here. So the first one we're going to make is public. Actually, before you even do that, let's create a constructor, because we have to ask for the connection string. Because we're going to, this class is going to talk to SQL data access, but it needs a connection string to do so. So let's do this. Let's ask for connection string, okay? And when we have that, what we'll do is we'll open a connection, private SQL data access, and we'll call this data access. Okay, and what we'll do is once we have the connection string, we will say data access equals new SQL data access and pass in our connections. Actually, we don't need to do that because we're asking for it every time, so we don't have to do that. I was thinking we're going to store it one time, but we can just do control dot here and initialize a private field. So what I did here is, it's a kind of a shortcut. It created a private variable, private read-only string, connection string, that I'm going to store for the length of time that this class exists. And we can use this over and over again. Okay, so I passed it in the constructor, and now I'm going to use it over and over again. Now I can create my public, and we're going to say that this is going to be a list, and this will be a list of our model. So public list, let's type string at first. This is what I do when I don't have my type yet. Okay, and I'm going to say my first action is to get all. Okay, so get all contacts. Okay, and then I'm going to pass in nothing. Okay, and remember, we're going to have a number of read and write actions. So this one was get all contacts. All right, and we're going to have to figure out what query do we write that will get all of our contacts. Okay, let's open up our database real quick and look at our contacts. We have contacts, but it doesn't have email addresses and phone numbers. Well, we're not actually going to worry about loading all of that. We're just loading our names. It's kind of like when you have your phone, you look at it, it's going to list all the people, but it doesn't list all their information too. You have to click on the person's name, and then it opens up a list of all of their information inside of that. Okay, so we're going to do the same thing here. Let's create a folder in Data Access Library. We're going to call this models. And a model is just a class with usually just properties in it. Let's create a class, and we're going to say basic contact model. And in this basic contact model, we're going to make public. We're going to say prop, tab twice, int ID, prop, tab twice, string first name, and prop, tab twice, string last name. That's going to be a basic contact model. The idea is that we have an ID, a first name, and a last name. Essentially, the same exact thing you'd find if you open up the contacts table. Okay, no links here, no email addresses or phone numbers. We'll get to that in a larger contact model, but the basic contact model is fine. Now I can come back over here to our list of string and say, well, actually, it's a list of basic contact model. Control dot here to add a using statement. Normally you want to name your columns. So ID, first name, last name. Okay, there's our statement. Now you can test that out by going over to SQL Server Object Explorer, and up here you see the new query. You click that, and then once it opens up, you can say select ID, first name, last name from dbo.contacts. and then you can hit the little run button here, which is Control-Shift-E. It's not F5. That's to run your application. You run that, and it returns values, but it returns 0 rows. We don't have any data there yet. That's okay, but it does work. Okay, so there's our SQL statement. Now we need to make a connection dynamic. This keyword means it can be almost anything. Okay? So we're going to use dynamic, and I'll show you why in a minute. Pass in our SQL statement. We already have that. Pass in our parameters. We don't have any, so I'm going to say new, and then open and close the curly braces. What this does, it creates a new anonymous object with nothing in it. That's what our dynamic will be. Now I can put comma and say connection string, which is underscore connection string. And now I have a call that's going to load data using this statement. It's going to put it into this model type, and it has no And now what we'll do is I'm going to come back to my user interface, my program.cs. Now what we're going to do is I am going to make a call to my SQL CRUD. So let's do this. Let's create first our SQL CRUD, but first we have to reference our class library. Okay? We don't have a reference from this project to this project. So let's right-click on dependencies in our console application, add a reference to data access library. Hit OK. And now that we have that reference, we can add a using statement up here using the data access library. Okay, I'll add another one for using data access library.models. We're going to need both of those namespaces just to shorten down our names. So let's first say that, let's say SQL CRUD, and we'll call it just SQL, equals new SQL CRUD, but we have to pass in a connection string. So get connection string. The default is fine. So we're going to use the default, and now we can use this with multiple calls. Let's just do the calls right in line. We could call them separately. I'm debating if we should do that. I kind of like doing that. Let's just do it. Private static void, and let's say read all contacts. Okay? And what this will do, we'll pass in our SQL CRUD. So we're going to pass that in as a parameter. I named it the same thing, but you don't have to. But now I can say, we'll just say var because it's shorter, and I'll show you why in just a minute. So var rows equals SQL dot get all contacts. Okay? And now, notice how short that is, but if you mouse over this, it says it's actually a list of basic contact model. All right? So now I can do a for each row in rows and do a console read line or write line in our string interpolation. And then in here we can say row dot first name space row dot last name. And actually, let's put the ID number in there too, just so we have it. So we'll say row dot ID and then colon space. So now we have 1 colon space Tim space Corey. Okay? Read all contacts. So we're going to pass that in here and pass in our connection to SQL CRUD. Okay? So what is this doing? Well, we first establish a connection to or an instance of the SQL CRUD class. And that class can do things like get all contacts, which is all it can do right now, but it can do that. We pass in the connection string so it can connect to SQL Server. And so now in our code, we can just say read all contacts, which is one method that all it does is it calls the SQL, which is SQL CRUD, SQL get all contacts, and then it's going to do something with those records. But now our code is very, very readable. Read all contacts. That's what's going to happen. Let's see what happens when we run this. Okay. 1 colon Tim Corey. So it has read one record from the database. So that's a success. When we have more than that, we'll hopefully read more. Okay, so SQL CRUD, we have the get all contacts. Let's do one more read so you can take care of the read. Then we'll get to the write methods. So this is going to be public, and it's going to be just basic contact model because it's get full contact by ID. Okay? And we're going to pass in the ID number. Now, basic contact model is not enough because we want the phone numbers and email addresses for this record. This is a little bit more complicated, all right? But what we're going to do is we're going to make 3 calls to the database, not 1, okay? So our end goal is going to have a contact with a list of phone numbers and a list of email addresses. So let's create that. So a new class, we're going to say, first of all, this is going to be the phone number model. And a phone number model is going to be have an ID and called list of phone number model called phone numbers. Okay? I think this structure will work. Okay, I think that if we fill in the basic information and then we fill in the email addresses and phone numbers, that'll probably be fine. So we'll say, our model dot basic info dot first name and dot last name. It'll be buried a couple steps deeper. This should work for now. Let's see how we like it and maybe if we want to change it or not. Well, I keep thinking this thing through and maybe I don't like it. Let's stick with it. We're going to stick with it for now. We can always adjust it later. Here's the thing that's going to lock you up sometimes in programming. It's the idea that you're thinking through so many different scenarios and the what ifs that can actually make you stop from doing anything. And you don't want that. You want to be able to move forward. You want to be able to make a decision. And so sometimes you have to make a decision knowing you might change it in the future. And that's okay as long as you think it through and are careful. All right, so we're going to make this choice, leave it like this for right now. Our full contact model has 3 models inside of it. Actually, 2 are lists. Okay, so this is going to be the full contact model, like so. But we can't just query the database. There's not really going to be an easy SQL statement that gets this back in this structure, because we're not looking for one row of information. We're looking for a row of information that also has a table of information underneath it twice. One table is going to be the, let's pull up the full contact model. One's going to be a table of email addresses and one's going to be a table of phone numbers. There's not a way to easily represent this in SQL. Now, it may feel like, if you've used Entity Framework before, it may feel like Entity Framework does this more easily, because you just say, hey, I want to also attach the email addresses and phone numbers. Behind the scenes, it's going to be what we're doing here. Okay, so it's not easier from a SQL perspective. It's still doing the same thing that we're doing. It's just that it's doing it for us. So there is a little bit of extra work we're going to do here. Okay, so what we're going to do first is get our basic contact information, which means we can actually just call get all contacts if you wanted to, but we're not going to do that because we don't want to get all of them. That's not efficient. We want instead to get the same SQL statement, but with an additional parameter, where ID equals @ID. This is a parameter. This is a parameterized SQL statement. We do not want to manually build this string. So you don't want to say and put like this and then say plus ID. Do not do that, because that leaves you open for SQL injection. Now, in this case, it wouldn't, because it's an ID or int, and integers, you can't put other values necessarily in there. But still, do not do that. Okay? You want to use a parameter like so. But how do you use a parameter? Well, what we're going to do is we're going to create, I'll show you in just a minute. Let's create our full contact model called output equals new full contact model. Now we can say output dot basic info equals, and then do our call, db dot load data basic contact model, and then dynamic, and then say pass in our SQL statement. Our parameters, instead of just being an empty parameter set like before, we're going to say ID equals ID, like so. And then we're going to pass in our connection string. We're going off the page here a little bit. And it's yelling at us. Why? Because it's returning a list of basic contact model, and we want just one. But we're limiting this to the ID, which is unique. It can only be associated with one record. Therefore, even though it's a list with one entry in it, or 0. Therefore, we're going to say dot first or default. Control dot add using system.link. And what this will do is it will return just the first record. And if there isn't that first record, then it's not going to throw an exception. Instead, it will return the default value, which is null. Now, it would be possible to just say first, like so. And then it's going to throw an invalid operation exception if it does not find that record. Okay? And so that might be okay, because if you don't find somebody, you're going to have to some way say, hey, I didn't find anybody. All right? An exception might be the way of doing that. Do you want this to be exception, or do you want to return or do an if statement and say, if it's null, then return back something else, either your own exception or not? I'm going to do that. I'm going to say first default, and then I'm going to do my own check. If output.basicinfo equals null, then I can do something here to tell the user that the record was not found. That could be a exception, or it could be return back an empty or a null full contact model. So you could just say return null. That might be indicative that something didn't work. We didn't find anybody. You asked for ID number 23. There wasn't one, therefore you get null back. I think that probably works the best. However, instead of returning null, you could say throw new exception, user not found. Like so. You wouldn't do the return as well, because this immediately exits your code. Exceptions are not always bad things. They're telling you something unexpected happened, or maybe something expected happened that was outside of what you were hoping for. Okay? We've talked through this before, but in this case, I think just returning null makes the most sense. But just note that you could exit your code at this point right here instead of going all the way through. Some people prefer to see the exits of their code only at the bottom, but I don't think it always makes sense. Like in this case, it doesn't make sense. If you said not equal to null and then did your code, then you can return at the bottom. That's possible, but it just makes your code really deeply nested, and I don't like that. Okay? So we've done the null check. So we've found a record here. And we've got the basic contact information. Now we still need to do more. We need to get the email addresses associated with them and their phone numbers. So let's do this. Let's go to our SQL Server Object Explorer. I'm going to pin this here. And I'm going to create a new query window. I'm also going to add some records to email addresses and phone numbers. Okay, so let's add some email by saying view data on email addresses. I'm going to create 2 email addresses for my record. tim@imtimcorey.com. my record, my contact ID, is associated with email addresses 1 and 2, which are these two right here. And that's correct. Now, let's create another entry, but this time in contact phone numbers. And again, contact ID is 1, phone number ID is 1, contact ID is 1, and phone number is 2. These numbers will change for you based upon how you entered and removed contacts. So don't expect 1 and 2 all the time. But in my case, number 1 and 2 for phone numbers are these two, and they're both associated with me, my contact ID number 1. Now I have all those in place. I have to figure out the SQL statement to get, let's just say, just the email addresses. So let's say select star from. I find it easier to start with select star. And we're going to say DBO dot, sort of email addresses. Email addresses. I'm going to give an alias of E. And an alias just makes it easier to reference. Okay, so I said E for email. That will work just for this query. Okay, so I'm going to say E.star for everything in email addresses. If I ran this right now, I'd get 2 email addresses. Okay, that's good. But we're not quite done yet. Now we want to link that to my personal contact information. So we need to do a join. Inner join. DBO dot, we're going to link to the contact email table. We're going to say CE for contact email on CE dot So now we've brought this in. These columns right here, ID and email address, these 2 columns are from the email addresses table. These 3 columns are from the contact email address. Okay? And that says, hey, these 2 are linked based upon contact ID number 1. Now, if we had more rows, you'd see duplicate information because you might see the same row, this row right here, you might see again, but only with contact ID number 2. Okay? And we're going to have that duplication. But for our case, this is fine because we're going to eliminate any duplication by saying only where the contact ID is 1, let's say. Okay? So where CE dot contact ID equals 1. And if we run this again, nothing's going to visually change necessarily, except it shrinks down that section. But what it does do is now if we had a second contact that also used tim@imtimcorey.com, it would not show because only contact ID number 1. Now we can say only give us stuff from the email address table. And if we do that, then we just get 2 records, tim@imtimcorey.com and me@timothycorey.com. These are the 2 records that are associated with my contact ID. Okay? Now we have this SQL statement. We can copy it. We can go over to SQL CRUD, and we can say SQL equals, and then paste this in. Now, if we say in front of this the @ symbol, this will allow us to have this multi-line like this. Now just note that it's actually going to put all these spaces in. So all these spaces and line returns, it will put in our call. Not the prettiest of calls, but it will work just fine. Typically, I don't do this way. Normally what I do is I would put a space and then I'd close my string, and then I'd add the next line and so on. But I think we're going to leave it like this for now. The one thing that I almost always forget, and you'll probably forget in testing too, but this contact ID right now is hard-coded to ID number 1. That will actually look like it's working in testing until you add a second record and hope for that record, and you don't get it. So let's change this to @ID. Now, I didn't declare that, but it's the same structure as what I did up here. I said, hey, I'm going to put an @ in front of something. That's now a variable. And that variable gets linked to the parameters we pass in this case, our ID. Okay, so now I can say output dot email addresses equals db.load_data. This is going to be our email address model, and it's going to be dynamic as our second value. That's almost always dynamic. SQL, and then new, where ID equals the ID being passed in, and our connection string. Now, we do not have to put on the end of this the first. We don't want the first here. We want the entire list of email addresses. We're going to do the same exact thing for phone numbers. Okay? Because now this has loaded all of our email addresses, which happens to be these two. It's loaded all of them into our email addresses for this contact. We'll do the exact same thing for our for our phone numbers. Let's copy and paste this. Copy and pasting is always very, very dangerous. I do it for demo purposes because it's quicker, but I would encourage you not to do it in real life, okay? Which means that, yeah, I'm a little bit of a hypocrite here doing it, but it's just faster, okay? But you have to check everywhere. Right now I'm loading the email address. I got to change that to be phone number, and I got to change the phone numbers, and I got to make sure that I'm passing in all the right information. Like right here, this is not email addresses, it's phone numbers, but I've got to figure out what that call is. So let's go over here and change that. So dbo.phone numbers, okay, and call it P instead of E, and join on not contact email, but contact phone numbers, CP on, and let's just do the whole thing over again, CP dot phone number ID equals P dot ID, where CP dot contact ID is 1. Let's run this query and see if we do 2 phone numbers, and these are just for that contact ID of 1. So now we have this, we can copy it, come back over here, we can paste it in place, we can make sure we format it nicely, and also make sure we change that 1 to be @ID instead. Now in theory, this is going to read all the phone numbers associated with our record, and it's going to put them into the phone name numbers parameter, which means, or property, sorry, not parameter, property. And now we can return output. And that's going to be a full contact model with the basic information, which is our first name, last name, and ID, and the more advanced information like a list of email addresses and a list of phone numbers. Now, this is a bit more complicated, and it does seem simpler to use an entity framework style where you say, I want this contact and I want their phone number information and their email address information. Behind the scenes, it's doing this work, only it's not nearly as clean as this most likely. Okay, so it is doing the same thing behind the scenes. And don't forget, you're going to have to support the behind the scenes code that Entity Framework writes. So this is what we have. This works just fine, hopefully. Let's test it out. So oops, I don't want to save my query. Let's save this though, and we'll go back over to our program.cs, and we're going to create a new private method. And let's actually copy this private method. Again, just for time's sake, read, instead of all contacts, read contact. We're going to pass in the SQL CRUD, and we're going to also pass in the contact ID. And instead of get all contacts, we want get full contact by ID and pass in contact ID. And now it doesn't have we don't do a for each, but let's save this console write line. And it's going to be not rows, because this returns one row. This is going to be the contact. And now I can say contact.id.firstname.lastname. And that's not going to work either because we don't have an ID. But if you notice, we can say contact.basicinfo. And it gets us our ID, our first name, and our last name. Let's do this, but let's put a breakpoint right here anyway, because we're going to look at our local window to see all the data about this contact. So read contact. Read contact SQL, and let's pass in our ID of 1. We're going to hard code that, just pass in our ID of 1. Let's comment out this line right here. Don't need it right now. And let's run this. It should pause at our breakpoint right here. It does. And let's look at our locals window. We have our contact, which has basic information of Tim, Corey, and ID of 1. Email addresses, it has 2. Me at timothycorey.com with an ID of 2, and also Tim at IamTimCorey.com with an ID of 1. We also have our phone numbers, which we have 2 of. ID number 1 is 555-1212, and ID number 2 is 555-1234. So it has the entire contact information in our code now. If we run this, continue, it's going to print out just the same information as before because that's all we asked for. So now we have our basic read in place where we're reading all contacts, and we also have a read contact where we're reading just one contact. Okay, we can comment that out, and now I can move on to how we write information. But first, I want to point out something. We are now getting information from a SQL server, and we're creating objects in C#. Before I had pointed out that you can use any user interface with your data access, that it's not limited to, okay, this is WPF or WPF data access, or this is ASP.NET data access, or how would you do this with an API? None of that matters because in our user interface, the only thing we're doing is making this call right here. That's it from a data access standpoint. Everything from that call on in is going to be in our class library. Our user interface console does not know about Dapper. It doesn't. That's installed in the class library. Our user interface, all it cares about is making this call right here. That's it. So all of our data access work is done inside the class library. Anything that can write C# can make this call and get back a contact record. I just want to point out to be very, very clear that it doesn't matter where you're calling this from. All right, let's move on to writing. Let's close out pretty much everything, all but this. Let's move on to writing data to SQL Server. We'll start by going to our Solution Explorer and going back over to our SQL CRUD. And in here, let's collapse some of these things down. We'll leave one open for kind of a comparison, this one right here. But we're going to do things a little bit differently because of the fact we're going to do a write. So let's start with our create. Okay, so we create one, we have to get that ID number back somehow. We're going to do a simple way. There are more complex ways to do this that can be better. So if we're using a store procedure, we could use the identity value that's created to get the value back. What we're going to do is just do a save, and then we're going to read again, but this time using the first name and last name and saying which record has these values. So it's not as efficient. We're going to do 2 calls, but it will work for our scenario. It's small enough, and it will show us how to do multiple different reads and writes. So I don't want to go too deep into identity and the similar things for SQLite and for MySQL. So we're going to do the simple way that will work. Okay? So we're going to get the ID number back by doing a lookup by the first and last name. Then we're going to identify if the phone number exists. Because if we already have a phone number existing, then we're going to have to just do an insert into the link table for that number. But if not, then we're going to have to do a look up the phone number, or I'm sorry, we're going to need to insert the new phone number. If not, and get the ID. Then do the link table insert. Okay, so if it already exists, the phone number already exists, we're just going to create a new entry in our link table, which is our contact phone numbers. Okay, contact phone numbers table. And that's if it already exists. But if it doesn't exist, we're going to insert a new record into the phone numbers table, get the ID, and then link. Okay? And then what we're going to need to do next is we're going to need to do the same thing for email. Okay? So there's a lot of logic going on in this create contact method. It's not simple. Let's start with the basics. Okay, so get the basic say the basic contact information. So we are going to say our db.saveData, And we don't have to pass in the type T here like we did up here in the angle brackets because of the fact that parameters is that type T. Therefore, it can infer what that type is. We don't have to specify it specifically. We're going to pass in our SQL statement we don't have yet. And we're going to say our parameters is instead of saying new empty or something like that, we're going to say contact dot, and you know what? That probably won't work because we're going to pass in the ID as well. So we're going to say new angle brackets like so, and say first name equals contact dot basic info dot first name, and then last name equals contact dot basic info dot last name. Okay, and we pass in the connection string. And after that, we can put our semicolon. We're going to break this line up into multiple lines here, so it's easier to read. In fact, I believe there's a refactoring for that. Let's do wrap long argument list like every argument, I think, is going to be good. Like so. There we go. And that's still not great. We can break it apart even further by wrapping this, but notice here the first name and last name are kind of grayed out. And the reason why is we can simplify this. We can simplify it by inferring the member name. What that means is we don't have to say that this is the first name property or that this is a last name property because this is called first name. So it's going to call it first name as the property name. So we can infer this last name as well. All right. So now we're passing an anonymous object to this first name and last name. Passing the connection string, we still need a SQL statement. So string SQL equals, let's create our insert SQL statement. Okay? We're going to pass this in right here. So an insert SQL statement is insert into DBO dot, and our table name is contacts. We're going to put in parens first name, comma, last name. These are the fields we're going to insert into the columns. And say values, and then put in parens at first name. That's the first parameter. At last name is our second parameter. Okay? So that and a semicolon at the end. You don't have to have this, but it's preferable. So we're saying insert into the first name column and the last name column the values of first name and last name parameters. Those parameters come from this object right here. So the first name and last name. Notice they match up. Okay, so it's going to take our first name and last name values. It's going to insert them into the first name and last name columns in the contacts table. That's our insert statement. Now we need to get the ID number of this contact. Here's what we're going to do this. I'm going to create a model. I don't have to. I could do something different. I'm going to create a model. I'm going to call this model the ID lookup model. And it's just going to be an ID number. That's it. So prop int ID. That's it. And that way, this will be the model I return with my lookup. So SQL equals select ID from dbo.contacts where first name equals at first name and last name equals last name, semicolon. So that's how you compose a select statement with multiple where clauses, okay? And our semicolon goes at the end as well. So you have a semicolon here and at the end. That's our SQL statement. Now we can say var ID equals db.load data of type ID lookup model and dynamic. SQL, the parameters, the same parameter list. And then we can say connection string. Okay, we can unpin this to see the whole thing. Whoops, I got a extra paren at the end. So there we go. So now we have our lookup, and this is going to return a list of ID lookup model. So we're going to say dot first or default. All right, so it should find it. In fact, you know what? We're going to do a first, because if there's not a first, we want to throw an exception. There's something went wrong if there's not a first. Okay, so our ID is now our ID lookup model. And now we can say, we should actually call this ID model. And with this, we can also do our refactor to wrap every argument. There we go. Makes it a little more readable. And now we have our ID model for our contact. We should say contact ID model. Or we could just say, you know what? We could grab the ID. There you go, contact ID. And now it's an int. Okay, so we're doing the first object and then grabbing just the ID of it. That's all we really need, is that ID number. Okay, so now you got the ID for the contact. Now we can verify if the phone number exists. Okay, so let's do that with an if statement. If contact dot, this is phone number, so phone numbers, and actually we can't do this yet. Let's start over, because phone numbers is a list. So for each, let's say for each phone number in contact dot phone numbers, if phone number dot ID is greater than 0, because by default the ID will be 0. That's the default value for an integer. So if it has a number greater than that, we know the phone number exists. Now this does mean that you could, in theory, create a new number that's the same as somebody else's number. That's possible. We're not going to worry about that. That would be more what we catch in validation somewhere. We're not worrying about that here. So if the phone number, the ID is greater than 0, then we know that we're going to do an insert just into the link table. Okay? But as I'm thinking about it, we're doing the insert to the link table here and here. What if we said, instead of greater than 0, we said equals 0? That way we know we have to do the insert and then get the ID. So let's do that. We're going to do the insert first. So we're going to say SQL equals insert into dbo.phone numbers. I believe it's plural. Let's just verify this. So phone numbers, and the column is phone number, values at phone number. tells you it's a parameter. We don't put the @ in the value here because it's basically infer. Okay, so we're doing a save data here. Now we're going to have to do the same thing as up here. We're going to get that value in the same way. So we're going to say, let's save it right back to the phone number.id. So phone number.id equals db.load data of type, and this is going to be, oh, that's not the one. It's going to be the ID lookup model, dynamic. Let's unpin this so we can have a little more real estate. The first one is our SQL statement, which we don't have yet. So don't think we already have it because we've got this and insert it again or try to. That's not what you want. Now we're going to say new, and actually it's going to be the same thing right here. So it's going to look exactly the same as that, not new. So we're going to pass in the phone number and the connection string. It's going to yell at us because let's reformat this first to wrap every argument. It's going to yell at us because this returns a list of ID lookup models. We're asking for int. Well, that's what it's going to say first and then ID. So now we're converting this to an ID and we're saving it to the phone number.id, which means that now down here outside the if statement, even if it was not 0, or if it was 0, it's going to insert it and then load the value up into this ID. If it wasn't 0, it's going to skip this section and go right down here where we're going to deal with the insert into that connector table. Okay? And that connection table looks like this. It's the contact phone numbers. So we're going to say insert into, SQL equals insert into, let's put a semicolon at the end now, so we have it. Insert into dbo.contact phone numbers, and there's contact ID and, let's just look real quick, contact ID and phone number ID. So phone number ID. The values are going to be at contact ID and at phone number ID. Let's make sure that close paren is there and the semicolon at the end of our SQL statement. Okay, so there's our insert statement for that connector table. But what we need to do is we're going to need to make sure that our variable names line up. Let's make sure they do. So db.saveData, pass in SQL, and then our new, let's leave it anonymous empty for now, and then connection string. So that's our insert, but we have to put our values in here. Where are our values coming from? Well, it's going to be our contact ID, which we have right here. But that's a different casing than this is. So we're going to say contact ID equals and contact ID. Now phone number ID comes from this, but it's called ID, not phone number ID. So again, we have to use the full name, not infer it. Like so. So you can't always infer it like we're doing up here. Okay, sometimes you have to actually spell it out, give it the property name you want it to be, and then map it to the value from wherever it is. Okay, so this should insert into the contact phone numbers table. Now, this is inside a for each loop, so it's going to do it for each phone number in the list. Let's do it again. That's that full path here. Let's do it again for the email address. Okay, so let's actually clean this code comment up and make it better. So actually, let's clear it out for now. You gotta be very careful that your comments don't become actually harmful to your code. Because that code is saying, that code comment is saying, and identify if the phone number exists. That's not what this for each is doing. That's down in the if statement. And it's saying if it doesn't exist. So just be very careful with code comments. We're going to follow the exact same pattern. I'm not going to copy and paste, but we're going to follow the exact same pattern as what we have right here. So for each, and this is going to be email in contact.email addresses. I'm going to say if email.id equals 0, then SQL equals, let's put a semicolon at the end first, come back and say insert into dbo.email addresses, email address, values, email address, semicolon, and then we're going to say db.saveData SQL new, and we're going to have email.email address, again inferred because it's named the same, and then connection string, like so. So that's the insert. Now we're going to get that value back out. So email.id equals db.loadData, the ID lookup model. Notice I'm using this model for more than one type because all it is the ID. Every table has an ID. Therefore, I can use this for looking up any ID from any table. Dynamic. We're going to say SQL, and then we're going to have new, and we're actually, let's back this out and just copy and paste for what we have right here, because it's the same ending, new email address and connection string, but don't forget we have to say first and ID. Now again, first will throw an exception if it doesn't find one, but since we just did an insert, it really should find one. And if it doesn't, that's a weird problem. Okay? And we want the exception to be thrown. So we're getting just the ID of that. And now, outside of this if statement, we can say SQL equals insert into DBO dot, let's grab that name. So that is the contact email. All right, that's this name right here. I like copy and paste because it's more precise than me typing out and getting it wrong. And the contact ID and the, is it email address or email? Yes, email address ID. Values, contact ID and email address ID. Like so. And now we can say db.saveData SQL new, and we'll start with contact ID equals contact ID, and email, well, I'll just paste it in, oops, email address ID equals email.id. We can pass a connection string in. There we go. And now we're good to go. So now we're inserting a value for each of the entries here. Now, if we wanted to, in this create, we could return the fully populated model with all the different IDs. If we want to do that, though, what we can just do is at the end of this, call get full contact by ID and pass in the contact ID we found right here. Now, let's see if this works. It's always good when you're writing code, test it as early as possible. So we've already commented out the read. Now let's, first of all, create a full contact model. So we're going to start with basic info. Let's start again. Basic info equals new basic info model. Inside here, we don't have an ID. We have a first name equals Charity. That's my wife. Last name equals Corey, like so. And then we're going to have an email addresses equals new email addresses. Oh, it's a new list of email addresses. Interesting. Let's just stop right there with our creation. Let's go over to our full contact model. I often forget to do this, and it can cause problems when you're loading it yourself. Equals a new list of contact model, and equals new list of phone number model. That way we can just add to these lists and not throw exceptions. So now we have this full contact model, which has a basic information. Let's add in a couple of email addresses and a couple of phone numbers. So user.emailaddresses.add. We're going to add a new email address model where the ID is getting blank. We're going to leave it alone. Email address equals nope@aol.com. No, I'm not giving my wife's email address. Sorry. Now let's just pretend for a minute that she also uses one of my email addresses. No, she doesn't, but let's just say she did, which would be the me@timothycorey.com, which means we can also say ID equals, I believe this is 2. Let's check to be sure. Now, we're doing this manually, so we wouldn't do it this way. We'd pick it from a drop-down list, probably in a Windows form or an ASP.NET web page. But we're doing it manually. We can only do it once because now otherwise we cause some problems with duplication. I want to see if we can do this once. Okay? And so we're going to look at our email addresses and just see, let's view data. And we'll view data on phone numbers too, so we have that information as well. So email addresses, the me record is that number 2. So, and I'm putting this right in main. I shouldn't do that. So we're going to move this out in just a minute. Now, user.phonenumbers.add. After we've completed that, it'll move it out. New phone number model. And this one, the ID equals 1. So she's going to use the same primary phone number as I do. And the phone number equals, I believe it's 555-1212. And then we'll do another one, but this is a new one that's just for her, and it's 9876, so it doesn't have an ID. Okay, so there's the record we want to create. So let's cut this out, and we'll say private void, static void, create new contact. And it'll pass in the SQL CRUD. We could have made this external to this main method. We could have put this external to it, and then everything could call it. But this works just fine. So we're going to create the model. Now that we have the model, then what we can do is we can say SQL dot create contact. We can pass in our user as the contact, and that's all we need to do. Now, let's just verify here for a minute that we only have 2 records for email address, 2 records for phone numbers, and if we go to these other tables, the phone for contact and the contact email has 2 records. did a lookup and it goes, no, I can't find that. So we did an insert. Let's look at what our value is. So our value is 5559876. Let's just do a real quick look and see if it updated our table here. It did. 5559876, and it did it twice. That's interesting that it did it twice. Ah, I know why. Because I told you we needed to update this SQL statement and we never did. That's my bad. So let's do this. Let's first of all fix a SQL statement. So SQL equals, and this is going to be our, I did this down here as well? Oh man, that's my bad. We need to do a lookup. So select ID from dbo.phonenumbers, where phone number equals at phone number, like so. And that's going to pass a phone number in and get the ID for us. We're going to do the same thing for email addresses. So I missed that, so that was following the same pattern. This is why it's very important to get your code right the first time before you follow it as a pattern. So this is select ID from dbo.email-addresses, where email address equals at email address, semicolon. Okay, now it does mean we're going to have some issues in our code. Let's go look at our contacts. We have Charity Corey, so we're going to delete that. It started to work, and it didn't. So Charity Corey's gone now. Email address, let's see if we have anything here. We don't. Let's go to phone numbers and see if we have anything here. We do have one. Let's delete that. And email addresses, we don't have anything there. I think that's all the things I need to check. Phone numbers, we checked the phone numbers. We did not. Okay, so let's delete those as well. Now, one of the things you'll note here, if you're a database person, is I haven't set up the foreign key relationship to have what's called referential integrity. So what that means is that I can delete the contact record without deleting all the things that it's linked to. That creates orphan records, and you really want to have a cascading delete. The best scenario is you don't delete it all. Okay, records don't get deleted; they get archived. But that's something we need to add at some point. We're not going to do it here because, again, this is not a SQL course. This is about how to read and write from SQL. So I'm not going to worry about setting up the foreign key relationships with referential integrity. If you want to do that, my SQL course covers that. Okay, so now we have all of our data back. I think we can set this up and run it again. Right, we're running it again. And in theory, it's already done. If so, you hit enter. Yep, I need to put some kind of output there and say, hey, it's done. Phone numbers. Let's refresh. We now have ID number 5 is 5559876. Note it's ID number 5, not 4 or 3. That's because we deleted 3 and 4. And we're never bringing them back. So therefore, it's ID number 5, and that's okay. Notice we also only have one extra phone number. This one right here, the 5559876, because my wife shares this phone number with me. So she should have a reference to 1 and 5. Let's look at the contacts table and find out what ID my wife is. She's ID number 3. So if we go to the contact phone numbers and do a refresh, we now see that there is 2 entries for number 3, a 1 and a 5. All right, so there's those links for us. We can close out that. Let's go to the email address and refresh this. And now we have nope@aol.com, but that's it. That's ID number 3. So my wife has access to 2 and 3. Let's go to contact email and see that contact ID number 3, my wife, has 2 and 3. Those are the 2 email addresses that she has a connection to. So it's linked everything up. And now if we were to comment this code out, let's come back up here, collapse this. We're going to comment this out. And this time we're going to do a read, but for ID number 3. That's my wife. So read contact. Let's put our breakpoint back in. And we're going to run this code again. And look at our locals window for contact. First of all, basic information, Charity Corey. Phone number, let's open these up. 555-1212, that's the one she shares with me. And then 555-9876, that's the one she has exclusively. Email address, here's her nope@aol.com. And then here's our shared me@timothycorey.com. So it now reads her contact information correctly as well, and just her contact information. So now we have an insert working, and it's a pretty complicated insert. We have a read one and we have a read many. Now let's talk about our update statements. So it's again, we're going to close all but this, and we're going to open up SQL CRUD again. And let's collapse down all of these. And actually, we'll leave, nope, not going to leave anything open. We're going to do a public void update contact name, right? And we're going to pass in the basic contact model called contact. Okay, we're going to do an update here, which is very similar to a save that we're doing up here. So let's leave this open just as comparison, which the save is like right here as well. So an update is a bit different in that string SQL equals, instead of saying insert, you say update, and not update into, just update, dbo dot, and this is going to be the contact table. And then you say set, or I give it the field to change. So this is going to be the, let's do first and last name. Set first name equal to @first name, comma, last name equal to @last name, where, and this is important, that where statement, ID equals @ID. Because if you don't pass in this where statement, or don't have this where statement, what this is going to do is going to update every single person to have the same first and last name. Every junior database developer does this at some point. They forget the where clause. And when you do that, you update everything. Not a good thing. Okay? You hope you have good backups. But make sure you have your where ID equals ID. Then we're going to do our db.saveData, pass in SQL, and instead of saying new and creating this anonymous object, we have an object that has first name, last name, and ID. That's all it has. And that's the contact object. So we'll pass that in. That's it. That's our update statement. Let's try it out. So we will have a private static void update contact and pass in SQL CRUD SQL, and let's pass in, that's it. We're not going to worry about having this be reusable. So we're going to create our contact look at the contacts list and look at it's Tim Corey. Okay, let's run this. And there's our command window, and it says we got an error. And it says invalid object name dbo.contact. That's because Tim has a spelling error. It's dbo.contacts. It's plural. Naming matters. So again, just to make sure, it did not update Tim and Timothy yet, because I was looking at the wrong table. Now this runs, it should say that's done processing. It does. If we refresh this table, it now says Timothy Corey. Okay, so we have an update statement going. Now let's come up to our program. We're going to comment this out so we don't keep calling that. And now we'll go back to our SQL CRUD and do one last operation, and that's going to be removing a phone number from a contact. So let's start out by saying public void remove phone number from contact. And we could do I think we'll just do a int contact ID int phone number ID, like so. And the reason why we need both is because we're removing a phone number from a contact. Remember that 555-1212? My wife and I share that phone number. So if I remove it, I can't delete the 555-1212 record because my wife is still using it as well. However, if I remove the 555-9876, which is my wife's phone number that's hers alone, I would want to delete that from the phone number table as well as that linking table. So I want to do both. Okay? So we're going to have to do a little bit more checking than just remove it. And again, typically we don't do many deletes in a SQL database. Typically you just have a flag that's like archive or set invisible or inactive or active, and you change it to say this record's no longer active or no longer visible. Because otherwise, you have to address all this referential integrity, all the places where that ID number is then used somewhere else. And you don't always get it right, or you have these cascading deletes, which is a little ugly. Imagine for a minute that I said, delete my contact information. Well, now it's deleting my contact information and my email addresses and my phone numbers. You may have to do that, but then think about if I had transaction history. For example, I bought 5 products and they were associated with my ID number. If I delete my contact information, it's going to want to delete those 5 purchases. Does that mean I lose those sales? Well, no. Do I want to have, phantom sales where I don't know where the money came from? Well, no. So how do I do that? Do I just leave an orphan record that says, someone bought this, but we don't know who because they're gone? That's not good either. And so that's why typically we archive this information. Now there is a balance there because then we're forever storing personally identifiable information. And that's not a good thing either. You don't want your credit card number or social security number or something like that stored for a long time, or even your phone number, your cell phone number. You don't want that stored in a database forever by all these different companies that capture it. Because if they get hacked, then your cell phone number is leaked. Again, not a great idea. Or your phone, your social, or your credit card number. So there is a balance here. And that's where you might say, we're going to keep the record, but we're going to wipe out the name on the record or any personally identifiable information and just say contact A is the one that made this purchase. Okay? So there's balances here. We're not going to get too far into that, but I just want to point that out, that referential integrity does mean that removing a record from a table isn't a trivial matter. So what we're going to do first is we're going to find, let's just document this. We're going to find all of the usages of the phone number ID. Okay? We're going to find all the links. And if there's more than one link, that means that we can't get rid of the phone number. If it's just this contact ID, then we can get rid of the phone number because that's the only contact that uses it. Otherwise, we need to just get rid of that link for that specific contact. Okay? That's the first thing I'm going to do. And so let's actually nest this. If one, then delete link and phone number. If greater than 1, then delete link for contact. Okay? That's what we're going to do. Now, to do that, we're going to need to do a lookup based upon the contact phone numbers list, which is contact ID, phone number ID, and ID. We don't have a model for that, so let's create one. And this is going to be the contact phone, if I spell right, phone number model. Okay, contact phone number model, singular, not plural. And then public, we're going to have an ID. We're going to have actually it's contact, it's all ints. So contact ID. And the other one is phone number ID. All right, so that's our contact phone number model. While we're here, we might as well create the other one. Nope, we don't need it. We don't need the email one because we're not doing deletes for that. So let's now do our find. I'll just come down here to do it. And we're going to say string SQL equals select ID, contact ID, phone number ID from DBO dot, and this is contact phone numbers, where phone number ID equals at phone number ID. Let's unpin this. And that's our select statement. We'll put a semicolon at the end of the statement as well. And now we can do a lookup based upon this. So we have our new model. So we can say var, let's say var links probably equals db.load data. And this is the contact phone number model. It's a long name, but it'll do. Dynamic. And we're going to say our SQL statement, and then new anonymous class, and we'll say phone number ID equals, whoops, not at, phone number ID, the one we passed in. And then after this, it's our connection string. And I know it's not longer than a SQL statement, but let's go ahead and wrap this every argument. All right. Now we have that, we can do our if statement. If links dot count is greater than 1, we know we have more than one record, then we're going to delete just the one entry. Actually, you know what we're going to do? We're going to say equals 1. Because we're going to, either way, we're going to delete the link. So delete the link and a phone number, or delete the link. So either way, we'll delete the link first. So let's create our delete statement. So SQL equals delete from dbo.contacts, not contacts, from dbo.contact phone numbers, where the phone number ID equals our phone number, and contact ID equals contact ID. Don't just use one, because otherwise, if you had more than one, you'd be deleting every entry. So we want to match only the one that matches specifically what our contact and our phone number. All right. So this SQL statement is just db.saveData, which sounds weird. We're saving data. Yeah, we kind of are. This is an execute or a do something on the server. Don't necessarily return data back. Okay. So save data SQL. Our new anonymous object. And it's going to start with phone number ID. Phone number ID and contact ID, contact ID. And that was passed in from the method. So there's our delete statement. Delete from the location and the where statement. Again, if you forget the where statement, you're deleting every row. Don't do that. Now, if there was just one, we can go ahead and delete the phone number as well. So in this case, SQL equals delete from dbo.phone numbers where ID equals at phone number ID, semicolon. db.saveData SQL new anonymous object. The phone number ID is this right here. And we need to have a connection string. And that's it. So now we've deleted from the phone numbers table as well. That's all we need to do. That's our logic. So let's save this. Let's go back to program.cs. We're going to call this. Remove. Oops. We have to actually create the private static void. Private static void remove phone number from contact. SQL CRUD. SQL. And we're going to pass in the IDs. So int contact ID. Let's move this off here. Contact ID and int phone number ID. Again, we're going to put them in manually like we did up here, but in a real application, we'd pass these in from a user interface where we get the values. Okay, so we're going to call the SQL.remove phone number from contact, contact ID, and phone number ID, and that's it. So there's not any extra work we're doing. We probably could have called this directly up here, but I like to have the same pattern. So SQL, and let's just start with 1 and 1. We're going to figure out what to actually call before we do that. So phone number. What phone number do you want to delete? Let's go to phone numbers. Let's delete one first that is used by just one person. So let's delete my wife's phone number. So ID number 5, and then her ID is 3. So 3 is the contact ID, and the phone number is 5. Okay, let's run this. Make sure we have our SQL right. Done processing. Let's go over to our table, phone numbers first, and 5 should be gone. It is. 5 is gone. If we go to our contact phone numbers and go to view data, there is no reference to 5. Now we do have a reference to phone number ID of 1, and that's twice. Well, I'm going to get rid of my phone number ID of 1. So I'm going to say 1 and 1. So person number 1, that's me, and phone number 1, which my wife and I share. That's the 5551212. Now notice we share it because we both have a number 1 for our contact ID. It should be that it just removes this, but we still have it here because my wife still uses it. Let's run this. And it's done processing. We can close it out. We can refresh this table. It's still there. We can refresh this table, and now my entry is gone, but hers remains. So now we have a delete that works properly as well. We can comment that out. That was a lot of work, a couple hours worth of work to get our SQL Server database created and then populated, and then all of our data access written in C# to talk to it. And it was a little complicated. Okay, so Dapper doesn't hide anything from you. It's not going to relieve some of the work for you. You have to do the work of creating the queries. But it also means that you know what the queries do, and you're sure the queries are doing the right thing. So let's go over. See it work the same way. Okay, and if it doesn't work the same way, it's a typing issue. Figure that out first. See where you've got assumptions, and then start moving on from there into one table in a database, and see if you can get CRUD to work on that, and then on from there. Because if you start slow and start building up, you'll get those skills, you'll understand it better, it'll start to click, and you'll have a lot more confidence. If you just look at this and say, wow, that looks overwhelming, and you don't do anything, then it will be overwhelming. You got to actually put the work in, okay? So try it out. Start with what I did, and then go on to this homework. Start simple with just people, then add addresses and employers. Try and map it out. If you don't get it all, that's okay. If you don't want to spend all the time, at least try and get some linking done, and make sure you do all 4 actions in CRUD: the create, read, update, and delete. Okay? Get that done, test it out, take some time, and then move on with the next lesson once you're done this homework.